Hello, good morning all. So we'll start the lecture. So what
Good.
we have completed in the previous lecture, I think interrupt part is completed. Okay, isn't it? So the third unit in that the interfacing part is there. So we'll start from LED interfacing. The basics related to the interfacing we have discussed in the previous lecture. And I asked to write the code for LED interfacing. Before that, how you are going to interface the LED to the microcontroller, that the physical connections or the hardware diagram we will see. Then we will see the code, and in the practical we will just implement the code. Okay. So in the theoretical part, we will theory lecture. We will discuss about the physical connections, the code, and in the practical session, I will just show you the output or the actual output of the particular code. Okay. So for LED interfacing, so there are two types: parallel interface and serial interface. The number of ways you could connect your LED to the microcontroller port pin. So obviously, any external device that could be connected with the microcontroller is always to the port. Okay. So here the three possibilities are given. So this is the you can say the way you can connect to the microcontroller. So here the resistor is not available, and here the direction is opposite. Okay. So this is the best way, but you can connect the LED number of ways, and according to that you have to modify the instructions or the logic in the code. That's it. Okay. So always the resistor is used. Why? Because that resistor is acting as a current limiting resistor. Okay. So for the protection purpose, the protection of the port and LED, the resistor is used. That resistor name is called as the current limiting resistor. Okay. So these are the two ways you can connect your LED to the microcontroller. We have discussed in the previous lecture. Means either I can connect the cathode of the LED to the port pin. So this is the port pin. Okay. Obviously, through a resistor, anode should be provided with the 5-volt supply, isn't it? And if you want to connect the anode of the LED to the port pin or the microcontroller port pin, then the cathode should be grounded. So that we have discussed in the previous part. Why the cathode should be grounded, and here the anode is given as plus 5 volt and cathode is connected to the port pin. Suppose if the port pin is connected with the cathode, so we can provide a particular logic to the cathode to the port pin, but anode should be at positive potential so as to make the LED on. Okay. In the same case here, the LED is connected, that is the anode of the LED is connected to the port pin. At that time, we have to provide the constant part, that is cathode is permanently grounded, and through port pin we can provide here logic 1 or 0. Okay. Now see, so these are the possible ways. This resistor is called as a current limiting resistor, and we will see how to calculate the rough calculation of the resistor, that what should be the rather value of that resistor. Now see, what happens is, now see, it is written LED will light when controller pin is low. That is, the controller pin is low means controller will, already you know the concept of sinking and sourcing the current. So it can sink the current from the plus 5-volt supply. Okay. So for that purpose, so if this is connected to the port pin, through port pin, what logic is to be provided to the cathode? Obviously 0. So already I told 0 means negative low, 1 means positive and high. Okay. So already anode is at high potential, so cathode should be at low potential, so as to make the LED in forward bias, and then LED will glow. When you want LED should off, LED should not glow, it will be provided with a one logic. Okay. So this is for this connection. This is called as the sinking. From 5 volt it will sink the current. Okay. Now as far as this other connection is concerned, the port pin to anode is connected to the port pin and cathode is connected to the ground. Okay, so cathode is already at negative potential or zero potential or ground potential. So as to make LED on through port pin, I should provide the logic 1, that is the high potential. So that's why it is written LED will light or LED will glow when controller pin is at high, and this is called as the sourcing. Controller is sourcing the current to the LED. So here it is sinking the current from the source, that is 5 volt source. That's why the name given as sinking and sourcing. Sinking is nothing but taking from another source, and sourcing is nothing but providing. So here controller is providing to the LED. Okay, so here obviously if 1 is given to the port pin, LED will glow, and if 0 is given, both are at the same potential, LED will not be in a forward bias condition. So that's why LED will not glow. So now you can understand key how the two possible ways of connecting the LED. So if in the practical, if you are connected by this way, so obviously external will ask, can I connect in other way? So you are already in the illusion ki yes, LED is connected, we have connected the LED in the write up or in the practical in one way, so other way there is no possibility of connecting the LEDs. No, there are two possibilities, as two leads are available, but according to that we have to do the changes in the diagram, changes in the logic, then and then only the LED will glow. So here from controller 0 should be provided so as to make the LED on. From controller in this case 1 should be provided so as to make the LED on. Yes? Now tell me any doubt regarding this diagram? प्रशांत गोजे द सेम लॉजिक इज अप्लाइड. लेक्चर एक 11:20 ला असेल तर 11:25 मॅक्स टू मॅक्स 11:30 पर्यंत इन केलं जाईल, त्याच्यानंतर नाही. त्याच्यामुळे परत परत डिस्टर्ब नाही करायचा. आज मी सगळ्यांना ऍडमिट करून घेतेय. येस, टेल मी एनी डाऊट रिगार्डिंग द सेम वॉट एव्हर आय हॅव डिस्कस. हे कोणाला कळलं नाहीये किंवा मॅडम 0 काय, लो काय, 1 काय ते कळत नाहीये, LED ऑन कधी होणार, हे लक्षात आलं तर तुम्हाला कोड लिहायला सोपं जाईल. कोड लिहिणं सोपं असेल तर त्या ज्या मॅन्युअल प्रोसेस आहेत प्रॅक्टिकलच्या, ऑल द टाइम क्रिएटिंग द प्रोजेक्ट, रायटिंग द कोड, क्रिएटिंग द हेक्स फाईल, डम्पिंग द हेक्स फाईल ऑन युअर 8051 microcontroller kit, they remain same for all the practicals. So the thing is, you should understand the logic of the code. Don't mug up the code. The code can be written by number of ways, not necessary. At the time of practical also, it is not necessary you should stuck with the code whatever we have taken at the time of practical. If you know, but you should stuck with the problem statement. So whatever the problem statement I have given, so if you have written your code and you could find the output by your own way of writing the code, that is fine, perfectly okay, no problem. But I should get the same output, that is the thing. You can write if you are comfortable, if you are familiar with the instructions and all, and if you could able to write the logic of the particular problem statement, code for that problem statement on your own way, it's perfectly okay. The thing is, by that logic you should get the same output. The condition is that. Okay, any doubt, anything which is not understood, madam? I don't understand this concept. This is the first part we have completed, how the LED is connected to your microcontroller. So for example, I have shown one LED. So if it is asked, draw the interfacing diagram of 8 LEDs connected to the microcontroller, the same way you can connect. If it is not mentioned in the problem statement, you can connect by your own choice. The logic should be proper. Yes, any doubt? कोणाला डाऊट आहे का याच्यात काही? नसेल तर डायग्राम ड्रॉ करा. I will provide 5 minutes, so draw the diagram. मी कोणाची नोटबुक विचारणार आहे, दाखवावी लागेल. 5 मिनिटं दिलीत मी, दोन्ही डायग्राम ड्रॉ करा, समजून ड्रॉ करा. कंप्लीट झाल्यावर मला सांगा. त्याच्या आधी 5 मिनिटाच्या अगोदर झालं असेल. 5 मिनिटं म्हणजे खूप झाले. एक 2-3 मिनिटं, पण कंप्लीट झालं तर सांगा. काही खूप मोठी डायग्राम नाहीये. हे थेरी पार्ट नाही लिहिला तरी चालणार आहे. त्याच्यात काय सांगितलंय की कधी ऑन होईल एलईडी, कुठल्या लॉजिकला. Okay. So these are the two ways. This is the first part related to the LED interfacing. So according to your understanding, you can just connect your LED to the port pin. Okay. This is applicable for any controller, huh? Not for 8051. The same logic for peak. So at that time, I will not repeat the same thing. Okay. So whatever may be the controller, obviously the external device will be connected to the port pin, and the logic for connecting the LED, as far as the LED is concerned, the logic, the way of connecting the LED is same. Okay. So how to calculate that resistor value? So how you calculate the resistor value? Obviously the voltage difference divided by the current. Okay. So according to that, the volt means 5 volts. So here this potential and this potential, so divided by the current flowing through that. So as far as this 8051 is concerned, so the current is 10 milliampere. So according to that, so you can calculate the rough value of the resistor. So V minus 1.7. What is that 1.7? Drop across the LED. Okay. So depending upon the LED, you have to again go for the data sheet and see the drop across the LED. And according to that, whatever the LED you are connecting, so divided by 10 milliampere. So V is 5 volt obviously. So you will get the R is equal to 330 volt. So the 330 ohm. So this is the way of calculating the resistor, and that resistor is named. Sometimes the examiner will ask, so what is the name for that resistor? So that resistor is acting as a current limiting resistor. So protection, for the protection purpose, that resistor is connected. Okay. So this is the way. In this way you can connect your microcontroller with the different LEDs. Now, the same simple program I have written here. The code will continuously send out port 0 to the alternating value 55 and AAH. So for that purpose, you have to write the code. Okay. So what I have written is, so that a value is taken in accumulator. So that accumulator value is passed to the port 0. So here in the problem statement, they have mentioned port 0. delay is called. Means that 5 value to the port will be for that much of time, whatever the delay you have written. Okay, and again AA value, again it is passed to the port, and delay is called. So delay you can write down now. You can write the logic for the delay by using timer as well as by using the simple registers we have discussed. Okay, so this is one of the tasks. Already I have given 3 tasks for the LED interfacing practical, so they are same as that, as this way you can write the code. Okay, so here also a simple logic is written. Key 5 is given to the accumulator to the port P1, A call delay, then delay is written. So here the delay is written by conventional method, that is by loading some value in the register and register will decrement. So the register value is 200. So from 200 to 0, it will remain in this loop only. Okay, so once R3 becomes 0, it will go to the return instruction. Return instruction executed, then it will go back to your main code. So how much time is required to decrease the value from 200 to 0? So for that much time, your port will get a value as 55, and then it is written as complement. So complement of 55 is obviously A, because 1 becomes 0 and 0 becomes 1. So you can just do. So just I'm telling you the number of ways you can write the simple LED interfacing code. So this is also one of the code, that single pin is available, that is the keep monitoring P1.2. So by that way, the number of ways to write the code. So you have to just concentrate on the problem statement. So what the problem statement is written. Okay. So the next part is related to the switch. So how to connect the switch? The same logic to connect the switch to the register. So, but switch is the input device. According to that, we have to read the status of switch. So just this is the way we will again see in detail the keypad interfacing. At that time again we will see in detail. So what do you mean by touch and release? So most important part is the LCD interfacing part. So in the number of projects you could require to display the message or display the status, display the output. So obviously it is output device basically used to display the data. So in this way your LCD look like actual picture of the LCD. Okay. So how to find out or how to select the LCD, liquid crystal display? These are the displays, one type of the displays. Nowadays the G LCDs are available, that is graphical LCDs. Okay, so these are the features of the LCD. So what is the feature of the LCD is, see, in a LCD controller is available, and that controller is HD44780. Now see, number of times this question will ask in your oral, but you don't know. In LCD, a separate controller is available so as to control the operation related to the display. Okay, and that controller name is HD44780. Okay, so alphanumeric LCD, this type of LCDs are alphanumeric LCDs. Always the size of LCD matters. So what is this 16 by 2? 16 by 2 is the size of LCD. So what it indicates? 16 by 2 means always first number is number of columns and second number is number of rows. So if you find 16 by 2 means 16 columns are there and such 2 rows are available. So 24 by 2 LCDs are available, 24 by 4 LCDs are available. So all the time, whatever may be the size, how to identify the rows and columns? First number is always the row, column, and second number is always the row. Okay, so 25 by 4 means 24 columns are there and 4 rows are there. So depending upon the choice, you can just select the LCDs. On the LCD, the blue black light is available. Then so as to adjust the contrast, the potentiometer is available. So I will show exactly the LCD at the time of practical, but these are the you can say the specification of the LCDs. The potentiometer is available. By changing that pot, you can adjust the contrast of your LCD. Okay, so that is available on the LCD, and the pixels dots are available, and that of 5 by 8. So 5 by 8 matrix is available so as to display the each character. Okay, so we will see the pin numbers of the LCDs. So for all the LCD, whatever may be the size of LCD, all the time the pins are almost the same. Okay, 16 pins are available. So see, pin number 1 is ground, pin number 2 is power supply, pin number 3 is VE. It is it is used to change the contrast. Then pin number 4 is resistor select, pin number 5 is read write, pin number 6 is enable. 7 to 14 pins means total 8 pins are data pins. Pin number 15 is VCC for backlight, and pin number 16 is VSS for ground. Okay, so see, these are the fixed pin numbers for any LCD, and according to that, why you require the pin numbers of any device? So for LED only two pins are there, so anode and cathode. So for LCD, when you want to interface the LCD to your microcontroller, obviously you should know how many pins are available to that LCD. Then and then only you come to know how many pins of how many port pins I required so as to interface that LCD device. So that's why these are the very important pins of the LCD. In that, the data pins are important, the enable, read, write, RS, these are the control pins, and these are the supply pins. So this is already for the backlight. So all these 14 pins are important pins. Okay, so just note down the pins within a 1 or 2 minutes. Just note down the pins, pin number 1 to 16, and name of that pin. Then I will explain the meaning of RS, read, write in detail. Note down the pin numbers. So LCD interfacing is very interesting topic. Everything is written, everything is with the pin numbers only. So what is the meaning of RS, what is the meaning of read, write and enable? So here, when you write the pin number 5, it is read, write bar. Huh? On W, there is a bar. The two operations are there, read operation and write operation. So both will not be at the same logic. R is at active high and W is at active low. So you have to write W bar, which is not shown on the PPT. So once you complete it, please just send me the message on chat box. So see, purposely I am not asked to write the LED code. So I have just given the hint. On the coming Monday, when your practical is scheduled, at that time you have to tell me the program for LED interfacing. I have given, I think, three tasks. So according to that, what will be the change? Basic structure, basic frame remains same. Only if I want all the LEDs, alternate LED and two LEDs on, two LEDs off, by that logic only the value will change. Basic structure of the program remains same. पूर्ण प्रोग्राम मध्ये चेंज करायची गरज नाही. 3 टास्क आहेत म्हणजे कोड एकच असेल, फक्त व्हॅल्यू चेंज होईल. I think it is completed. So next
Yes, ma'am.
part. Next part. What do you mean by RS? What do you mean by read write? And what do you mean by enable? Now see. In a LCD, there is a, as there is a controller, there is a register called register select. So what it will do is, so as to write the any data on the LCD, standard commands are there. That command should be initialized, and that commands are available in the command register. When you want to send any data, that data is to be written in the data register. So as two registers are there, so while sending the command, I have to select the command register. When sending the data, user has to select the data register. So for that purpose, RES bit is available. That bit is called as the register select bit. RES stands for register select. So when RES is equal to 0, command register gets selected. When RES is equal to 1, data register gets selected. So that you have to remember right now. Then we will see how this is useful in the code. Okay, so one pin is called as an RES pin, and that pin is nothing but register select. When RES is equal to 0, command register will get select, and RES is equal to 1, data register gets selected. Okay, and again here also read write bar. So when as far as this LCD is concerned, as this is an output device, but there are the possibilities of two operations. Now I can read the data from LCD, or I can write the data to the LCD. That reading operation is very rarely required, but that is the possible operation from the LCD. So for that purpose, so as to select that operation, the read write pin is available. So if you want to write the data to the LCD from microcontroller to LCD, obviously the status of that pin read write bar should be 0, because read write bar is active low. So if this pin is 0, write bar gets activated and the write operation will be selected. Read write bar is equal to 1, read operation gets selected high, and that's why we can read the data from the LCD. So most of the time 90% of you require the write operation. So in some of the kits, in some of the boards, read write pin is permanently connected to ground. So if read write pin of the LCD is permanently connected to the ground, only possible operation with the LCD remains. Yes, which operation? Hello. जर read write pin मी ground ला connect केली, ground ला connect केली म्हणजे काय?
Right.
0 मिळणार. येस, राईट ऑपरेशन. आणि जर मला नाही परमनंटली कनेक्ट करायची तर थ्रू प्रोग्राम, थ्रू कोड, I can select 1 or 0. In some of the kits, some of the boards, the read write pin is connected permanently to the ground, because right now I told number of times or mostly we require the write operation because LCD is a display device. Okay, so for that purpose this read write pin should be 0 for the write operation. For read operation, it should be 1. So this is the first pin. These three pins are called as a control pins. Okay, and the most important pin, which is called as the enable pin. So this is the enable signal. So for what? Obviously the name itself gives the meaning. The high to low pulse must be applied to the pin in order to transmit the data to the LCD. When you want to send the command to the LCD from microcontroller to the LCD, or when you want to send data, command is also one type of data. So at that time, so as to latch that data, latch means save that data, so as to save that command onto the LCD, it requires some time. For enabling that operation, it requires some time. So for that purpose, so as to enable that, high to low pulse is required. So the pulse must be minimum 450 nanosecond. So nanosecond. So this is the minimum requirement. So when that much time is there, so one data or one command will be transferred successfully from microcontroller to the LCD. Okay. So for that purpose, for all the time, you require the enable pin. If I want to send one command, obviously enable pin is required, enable signal is required. For second command, third command, then second data, likewise. Whatever you are sending, transmitting from a microcontroller to the LCD, so enable signal you require. Then and then only that signal, that data, that command will be latched, will be stored in the LCD. Okay, so these three are very, very important pins so as to understand the LCD programming, so as to understand your LCD model. These are called as the control pins. RS, register select, two registers are available at a time. One gets selected by giving the providing the proper logic. Read write, the write operation or read operation, and enabling that signal so as to transmit the data to the LCD for a particular during the particular time. So these are the three pins, and then the DB0 to DB7, these are the data pins through which actually the command or data will be sent from microcontroller to LCD. How the data will be sent through the microcontroller to the LCD? Obviously to these pins. These pins are called as the data pins. DB0. Sometimes in some of the books they have mentioned by D0 to D7, DB0 to D7, DB7. So likewise, but D stands for the data pins. So these are the control pins, these are the data pins, and these are the supply pins. Okay, so in this way, we can connect the LCD to your microcontroller. Now what I told is LCD, as far as our normal LCD is concerned, all the time we will use the 16 by 2 LCDs. Okay, so what is the meaning of 16 by 2 is, in a single line two rows are there, means two lines are there, and in each line 16 such columns are there, and one column consists of 5 by 7 dot matrix. Are you able to observe these dots? And all the time, as far as we have seen the specification of the LCD, this and on this particular column, a character or a letter will be displayed. Okay, so all these are the 5 by 7 dot matrix. Such 16 dot matrix are available in a one line. So the position will be 0 to 15 and 0 to 15 likewise, or depending upon the address size also it will get changed. So 0 to 15 means total 16. Okay, so two lines are there, so 16 and 16, total 32, means 32 characters, 32 letters can be displayed on 16 by 2 matrix, 16 by 2 LCD display. Similarly, if your requirement is higher, so you can go for the higher size of the LCD, or you can do the scrolling of the message. Likewise, options are available. But the straightforward meaning of 16 by 2 LCD means that LCD consists of two lines, means two rows, and in each row 16 columns are there. A letter can be displayed on a single row, a single column. Okay, so by that logic, 32 characters, 32 letters, 32 numbers can be displayed on a single LCD. Okay, so this is the meaning of that point. And this is actual interfacing of the LCD with your microcontroller. Now see, in the third unit, number of interfacings are there. So this part remains same, left part remains same. Means microcontroller part remains same. And this rightmost part will go on changing. Yes? Do you agree with this? Yes? Why the rightmost part will change? According to the device, the pin numbers will change. The structure of that device, depending upon that, the number of pins required, that will change. But all the time you have to show the microcontroller by this way: microcontroller's VCC pin, Microcontroller ground pin. Now see, what is this EA pin? Can anyone tell me the logic of EA pin? Yes? EA stands for
enable.
enable. मग LCD मध्ये परत enable कशाला असतं? What it enables? What it enable? आणि आता आपण काहीतरी एक्सटर्नल कनेक्ट करतोय तेव्हा EA पिन दाखवली आहे तिथे. आणि मग इनेबलला आपण जनरली EN लिहितो ना, इथं EA लिहिलंय. त्याचं काही लॉजिक आहे का? पिन डायग्राम आपण प्रत्येक पिन बघितली होती. एक्सटर्नल ऍक्सेस, जेव्हा कुठलंही डिव्हाइस एक्सटर्नली आपण कनेक्ट करतो, तो एक्सटर्नल ऍक्सेस पिन जर ऍक्टिव्हेट नसेल तर तुम्ही जे काही कनेक्ट करता इट हॅज नो यूज. ठीक आहे. तर ते VCC, क्रिस्टल आणि रिसेट सर्किटरी, हे दोन्ही सर्किटरी आपण बघितल्यात. 11.0592 मेगाहर्ट्ज हे फिक्स असणार आहे कुठल्याही इंटरफेसिंग मध्ये. LCD इंटरफेसिंग असू दे, LED इंटरफेसिंग असू दे, मोटर इंटरफेसिंग असू दे, ADC इंटरफेसिंग असू दे, जे काही इंटरफेसिंग असेल ते काय होईल, कुठला इंटरफेस डिव्हाइस करायचा आहे त्याच्यानुसार हा राईट साईडचा पार्ट चेंज होईल, पण बेसिक कंट्रोलरचं तर सेमच राहणार आहे. 8051 कंट्रोलर सोबतच जर इंटरफेसिंग करायचं असेल तर त्याचं हे जे काही क्रिस्टल सर्किटरी, रिसेट सर्किटरी, VCC ग्राउंड सेम राहणार आहे. आणि पोर्ट कुठला सांगितलाय स्टेटमेंट मध्ये त्याच्यानुसार पोर्ट चेंज होतील. सपोज मला आता LCD सांगितलंय P0 पोर्टला, तर मग फक्त पोर्ट चेंज होईल, बाकी वे ऑफ कनेक्शन सेम राहणार. येते लक्षात? आता LED साठी मला 8च पिन लागणार आहेत. 8 LED ला, प्रत्येक LED ला एकच पोर्ट लागणार आहे. दुसऱ्या LEDचं पिन तर ग्राउंडला कनेक्ट करायचंय. पण आता LCD मध्ये ऑलरेडी 14 पिन्स आहेत, त्याच्यामुळे आपल्याला त्यातले 8 आणि हे डेटा पिन्सचे 8 आणि हे 3 11 पिन्स तर लागतात. बाकीच्या VCC आहेत तर त्यांनी सप्लायला कनेक्ट केलेले आहेत. ठीक आहे. तर त्याच्याप्रमाणे तो डिव्हाइसची पिन नंबर माहिती असणं गरजेचं आहे. देन यू कॅन एबल टू ड्रॉ द इंटरफेसिंग डायग्राम. ही इंटरफेसिंग डायग्राम आता ड्रॉ नका करू, नेक्स्ट लेक्चर मध्ये मी तुम्हाला ड्रॉ करायला सांगते. सध्या अटेंडन्स द्या and can leave the group. आज एवढं बास. टुडे इज 22 ना.
Yes, ma'am.
रोल नंबर 1. रोल नंबर 1, 2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5, 6,
Present, ma'am.
7, 8,
Present, ma'am.
9.
Present.
हा ठीक आहे. 9,
Present, ma'am.
10.
Present, ma'am.
Ma'am, 7 present.
मध्ये कोणीच डिस्टर्ब नाही करायचं. जेव्हा चालू असेल तेव्हा तुमचा नंबर गेला तर थांबायचं, मग मी बघेन काय करायचं ते. मध्ये डिस्टर्ब नाही करायचं अजिबात. 11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14,
Present, ma'am.
15,
Present, ma'am.
16 नाहीये, 17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20, 20, 21,
Present, ma'am.
21, 22, 22, 24,
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am. Present, ma'am. Ma'am.
26. मी
Present,
जो
ma'am.
नंबर घेतलाय त्याच नंबरनी हे करायचंय. मी काय सांगितलं, जर तुमचा नंबर होऊन गेला असेल तर बोलायचं नाही. 26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29.
Present
29.
ma'am. Present ma'am.
30.
Present.
31. 31. 32.
Present, ma'am.
33.
Present ma'am.
34.
Present, ma'am.
35.
Present ma'am.
36.
Present, ma'am.
37.
Present, ma'am.
30, 38.
Present ma'am.
39.
Present ma'am.
40.
Present ma'am.
40.
Present.
40 present है.
Oh ma'am. Present.
41.
Present ma'am.
42.
Present ma'am.
43.
Present, ma'am.
44.
Present, ma'am.
45.
Present ma'am.
46. 46. 47. 47. 48.
Present ma'am.
49.
Present ma'am.
50.
Present, ma'am.
51.
Present, ma'am.
52.
Yes, ma'am.
53.
Present, ma'am.
55.
Present ma'am.
56.
Present ma'am.
57.
Present, ma'am.
58.
Present, ma'am.
59.
Present, ma'am.
60.
Present ma'am.
62. 62. 63.
Present ma'am.
64.
Present ma'am.
65. 66.
Present, ma'am.
67.
Present ma'am.
68. 68. 69.
Present ma'am.
70.
Present ma'am.
71. 72. 73. 74.
Present, ma'am.
75. 76.
Present, ma'am.
77.
Present, ma'am.
78. 78. So you can leave the meet now. Thank you all. आता कोणाचा काही प्रॉब्लेम असेल तर एक एक बोला.
Ma'am.
एका वेळेस एकानी.
रोल नंबर 7.
काय करत होता?
मॅम जरा नेट कनेक्शन स्लो होतं.
नेक्स्ट.
Roll number 31 present.
नेक्स्ट. बाकी झाले सगळ्यांचे? ओके. सो यू कॅन लीव द मीट.
Thank you ma'am.
थँक्यू ऑल.
Thank you, ma'am.
सायली राणे ऍडमिट आत्ता करते का काय?